Okay, this problem right here, number 10, on assignment 26, it's asking us to find all extrema, if there are any, and intervals where our function is increasing and or decreasing. And in this case, we're talking about a parabola. So you already know a lot about a parabola from what you learned in Algebra 1, pre-algebra, and Algebra 2. For example, you know how to find the x-intercepts of this parabola by setting it equal to 0, factoring it, and then solving. So I'm just taking you down a memory lane trip here, and you know that this is where this quadratic function crosses the x-axis at -4 and +1, and we used to call those the x-intercepts. Okay? So even in Algebra 2, you learned how to find the vertex of this parabola, which is really the relative extrema of this parabola. So what calculus enables you to do is it enables you to figure out or analyze your functions that you already know, but in more detail. And it also enables you to calculate some of the same things, but faster. So when you're given a relative extrema increasing or decreasing question, step 1 is to take f and derive it. And when I do that, I get -3 minus 2x. Part of step 1 is to set the derivative equal to 0 and to solve. And you get x is equal to -3/2 or -1.5. So step 1, derive, set it equal to 0, and figure out all critical points. Critical points are important because critical points could become relative extreme. And that's what we're looking for. And that is your step 1. So to figure out whether or not your x is a relative extrema, whether this point is a relative extrema, you need to make what's called a sign chart for f prime. So we take the critical point and we put it on our number line, the -3/2. And then we take a number that is smaller than -3/2, like -2, and we plug it into the derivative, and we calculate and figure out what this sign is. Well, this is going to be -3 plus 4. This result is +1. So we're not concerned about the exact result. We're just concerned about whether the result is positive or negative, and then we put that on our number line and on our sign chart. We pick a number bigger than -3/2, like -1. Always plug it back in the derivative when you're making the sign chart, and I get -3 plus 2, or -1, or more simply, a negative number. And if you realize that there is a change of sign on f prime, then that particular x is a relative extrema. So all you need is a sign change for a relative extrema. Now the way the sign changes is important. So the sign will tell you what's happening with f. So if f prime is positive, it means that f is increasing in that interval. And if f prime is negative, it means that f is decreasing in that interval. And since your function is going from increasing, like that, to decreasing, increasing to decreasing, right around x equals -1.5, you can tell that this relative extrema is a relative max. If the signs were opposite, in the opposite way, it would have been a relative min. So now we have answered the entire question for the entire domain. We have figured out intervals of increase, intervals of decrease, and all relative extrema. So what we want to do now is we want to summarize the sign chart using different notation. But we have essentially answered the question, and that is step 2. All right, your final step is to kind of translate your sign chart, your number line, into interval notation and point notation. So what we have here, moving from left to right, is we have our entire domain analyzed from -∞ up to -1.5, which is the most important x in the entire domain, up to +∞. And that's really the power of calculus, is it enables you to find some of the most important x's, most important points in an infinite domain. So, from negative infinity up to negative 3 over 2, this is interval notation, from this x to this x, my function f is increasing. And then, at x equals negative 3 over 2, comma, y equals, I need to still figure that out, I know that I have a relative extrema, more specifically, a relative maximum. And then from negative 3 over 2, I'm essentially just translating my sign chart into interval notation. From negative 3 over 2 up to positive infinity, I know that my function f is decreasing. And that is really the power of the derivative. It helps you to figure out critical numbers, which then helps you to analyze the function in its entire domain. And that is step 3 and the final part of this process. I now want to show you what you did using algebra and calculus. It's actually quite remarkable, all the different things that you can analyze about your function 4 minus 3x minus x squared. Algebra enabled you to figure out that the x-intercepts, by solving this equation, are negative 4 and positive 1. Algebra could also have helped you to figure out this vertex. But instead we used calculus. So we set the derivative equal to 0, and we got x equals negative 1.5. And after making a sign chart, we figured out that negative 1.5 was actually a relative max. And you can see here that it is a relative max, that the vertex of this parabola gives you a relative maximum right here at negative 1.5, comma 6.25. The final thing is that the sign chart told us that we were started off our function by increasing, and then once we got to our max, we started to decrease. So, one way to think of calculus in terms of studying functions that you have already learned about in trigonometry and algebra is that calculus just gives you more information about the same function that you're already familiar with.